Okay, section 3, names and formulas of ionic compounds. Ionic formulas, these are the overall charge of the entire compound must be neutral, so it has to have a charge of 0,
Okay.
and have the lowest ratio of elements possible. The reason we say lowest ratio of elements possible is because sometimes you'll, when you start combining them, you might get 2 of one element and 2 of the other, but you need to reduce it to make it the lowest ratio of 1 to 1. The rules. Cations are always written first. So your positive charge will always be first, and then your negative charge. That's just how it always goes. Subscripts represent the number of ions of each element in the compound. So the subscripts are the little numbers that are written on the line.
Okay.
And then your superscripts are only used to represent the oxidation number or the charge of the ion. You do not use the charges in your formula.
No.
So we see that every once in a while.
Yeah.
Don't do that.
No.
Okay. Monatomic ions. So this is one atom ions.
Okay.
Okay. You're going to combine with another monatomic ion, and they form a binary ionic compound, which we've already covered. But remember that the charges you put in the chart for section 1 are the ones you're going to use.
That's
Multiple
fine.
charges can be found on the periodic table.
Okay. So the multiple charges are the ones that are coming from your transition metals. Okay.
Binary ionic compounds. Let's practice making this compound. So you've got
I
sodium.
love doing these. Sodium is Na.
Oh no.
Back it up. Don't get excited.
Okay.
What color? What color? What color?
I don't know. We'll just see what happens.
All right.
Red. Okay.
All right. So we write
Na.
Na. We give its charge, which is a +1.
Yeah,
Because
it's in group 1.
You're so smart.
Yeah.
Bromide is actually coming from the bromine because it's the anion. The name was actually changed to the IDE in the name. It is in group 17, which means it has a -1 charge. They are a 1-to-1, and so they kind of cancel each other out.
Yeah.
And we just have to write NaBr.
So you want to make sure that this charge is canceled out by that charge, so NaBr will be your compound. Notice it's a binary ionic compound. There are only 2 elements present here.
Okay.
Okay, lithium. What's the symbol for lithium?
Li.
What group
Also
is
in
it?
group 1, so it's
Okay.
+1. Nitrogen's in group 15, which means it has a 3- charge.
Okay.
Minus. They don't match.
No, they don't.
What are we going to do?
Well, lithium has a +1.
Yeah.
Nitrogen has a -3.
Okay.
I would say we have 3 lithium.
To every 1 nitrogen?
Yeah.
So that we can have a neutral charge of 3+ and 3-.
Yes.
Okay.
So I'm going to write lithium and then a small 3, or the subscript of 3,
So that says we're using 3 lithiums.
to every 1
One.
nitrogen.
Mm-hmm.
Notice I don't have a 1 here.
Nope.
You don't need to write the 1. If there's no number there, we assume it's 1, or else you wouldn't have written the element.
Okay.
Okay. Aluminum, what is the charge?
Aluminum's a 3+.
Okay.
Oxide's a 2-.
Okay. Oh, we got to do a little bit more math here.
Great. So to neutralize this one, I'd probably go to a 6. So then we would need 2 aluminums
Yep.
and 3 oxygens to get a 6+ and a 6-.
Yes. Okay. So let's put in parentheses. Now we've got a +6 here, and we've got a -6 here. So if you add those together, you're going to get a 0.
Yep.
Okay. Polyatomic ions. You've heard of these before. You've used some of them before, but now we're going to introduce you to a lot more. And they're on your periodic table. They are mostly, there's a lot of the ones that are listed here on your periodic table.
But
But,
cheat sheet.
oh, sorry, cheat sheet, not periodic
Cheat
table.
sheet, bottom corner.
Yeah, first page. It is a long list, just like what we've got here.
Yeah.
There's some
even more.
on your cheat sheet that are not on this list. Okay. Oxyanions, that's a mouthful, are polyatomic ions with oxygen that end in either ITE or ATE.
Okay.
And they're very specific. So again, if you're going to write, you have to be really clear on what you're talking about. If you write nitride, you're talking about just nitrogen. If you write nitrite, let's go over to your chart, you're talking about NO2 with a -1 charge. If you're talking about nitrate, you're talking about NO3 with a -1 charge.
Okay, so the ATE kind of means that there's more oxygens compared to the ITE.
Yes.
Right.
So that when there's more than one polyatomic ion, you must use parentheses around it, and then you write your subscript after that.
Okay.
And then down here, these are examples of polyatomic ions. Here's sulfate. Yes, sulfate.
Mm-hmm.
It's got 1 sulfur and 4 oxygen. So this acts as 1 unit. So
That whole thing goes
Yeah.
to the other.
this all bonds to the other
Okay.
element or compound. Okay, and then again, if you're going to draw an ion, you need to do the brackets with the charge on the outside.
All right.
Okay, polyatomic practice. Okay, so now we've got potassium.
Potassium's in group 1, so it's a +1.
Yes, potassium is straight from the periodic table. It is not a polyatomic.
No. Now the nitrate, the
Uh-huh.
ATE, means that I'm going to look on my cheat sheet.
Right.
I'm going to look in that bottom corner. It's in alphabetical order. Nitrate is NO3
Very good.
-1.
Okay.
We have a +1 charge and a -1 charge. They balance already, so we can cancel out the pluses and the minuses and just
Yeah.
write it all together.
Yeah, it's
Why are you putting 3?
because it's nitrate.
Oh, they can't get rid of the 3?
No,
Oh,
you
they
cannot
try to
of
get rid of
this.
the 3.
You cannot get rid of any subscripts. Don't try it. Don't change them either. Do not change them.
If the subscript is on here, it stays on here. All right,
Let's try aluminum sulfate.
aluminum, Al, 3+.
Yep.
Sulfate,
Okay, that would be an SO4, and it has a -2 charge. All right. So again, we've got kind of what we had last time with aluminum. You'll see this often with aluminum. A lot of times you have to bring up that charge to a +6 in order to balance it out. So if we have 2 aluminums, that will make that a +6.
all right.
If we have 3 sulfates, that's going to make that a -6. So how do I write it if it's going to have...
Well, if you put the SO4 and then try to put a 3 down there, you're going to have a 43.
That doesn't work.
No, so we're going to have to use parentheses to keep the sulfates together and show that there are 3 of them.
Yeah.
We use the parentheses.
Remember, the sulfate is
Oh,
4
Oh.
oxygens.
oh,
Okay, so this means that you've got 3 of these attached to 2 aluminums.
that's big.
So if you tell me that you have 43 oxygens, that's not right. If you multiply 4 times 3, that's not right
No.
either.
Uh-uh.
Because then you're telling me you've got 12 oxygens for every 1 sulfur. That's incorrect.
No.
Okay? Keep it in parentheses. It'll make your life easier.
Yeah.
Calcium.
Ca, it's in group 2, so we got a 2+.
Phosphate.
Phosphate is PO4, and it's a 3-.
Okay? So again, we got to bring it up to a 6 because we have a 2 and a 3. So calcium, I'm going to have 3. And phosphorus, I know I have more than 1. Sorry, phosphate, I know I have more than 1. So I need to do PO4 parentheses 2.
Bingo.
Okay?
I like these.
Crisscross method.
Oh,
Now,
my favorite.
this is pretty easy. You're going to take the charge of the cation and make it the subscript for the anion. Then you just take the charge of the anion and make it the subscript for the cation. Sometimes it works that easily and you don't have to do anything else. Sometimes you have to reduce it. But remember, subscripts are always positive and you always reduce it to the lowest ratio. So the example down here, lithium as a +1. Take this charge, move it down to the oxygen. Notice nothing's written there because the 1 is understood. The 2 from the anion oxygen is going to go down to lithium, so you have Li2O.
And we do not take the pluses and the minuses.
We do not.
They get dropped away.
Don't tell me there's a
Ignored.
-2 lithium. That doesn't work. Crisscross practice. Okay, aluminum again.
Yay.
We love aluminum, I guess.
Al3+.
Woohoo!
If you don't have that memorized after this, you're going to have some problems.
Fluoride. It's in group
-1.
17.
We got a 3 and a 1.
Crisscross. That
So,
gives you
Al1,
Al.
fluorine 3.
Okay,
Done.
done.
No math.
Calcium.
Love it.
2+.
Oxide.
Oxygen.
2-.
2-.
2, 2. Cross each other out, ignore.
Okay, so
Oh,
If you write it this way,
that's not
that's
simplified.
not correct. Simplify it down to here because it's 2 to 2, which is really 1 to 1.
Yep.
Calcium and nitrate. Ooh, we threw a polyatomic in there.
Wow, that was tricky.
It is tricky. Okay. NO3. And it has a -1. Okay, so crisscross it down. Calcium would get a 1. NO3 will have 2. So give me parentheses,
Yep.
please.
Can't put the other number down. Now, the other thing about it is some of the polyatomics do not have a number down there, and such as OH, hydroxide. If you are bringing a number down there and it's polyatomic, you better give parentheses every stinking time, even if there's no superscript that's already there.
Yeah, if you tell me that there's 2 H's, now you've changed the whole compound.
Right.
Okay, naming ionic compounds. So here are the basics. You're going to name the cation first because it appears first in your formula. The monatomic cation, you're just going to use the element name from the periodic table.
Mhm.
But for transition metals, you're going to identify it using Roman numerals and parentheses, which
Okay.
we've talked about
Yep.
before. The polyatomic cation, you're just going to use the name of the ion. There is really only
There's a couple, that's about it.
1 or 2. Ammonium is a really familiar one,
And hydronium.
and hydronium.
That's about
But
it.
for the most part, you're going to see ammonium as your cation. You just use that word. Then you're going to name the anion. And for the monatomics, again, you're going to use the root word and add an IDE. For the polyatomic, you're just going to use the name from your cheat sheets.
Cheat sheet, easy stuff.
Okay, naming practice. So we've got a CU. What is that?
That's a copper. And copper is found in the transition group right in the middle.
Very good.
So we're going to have to figure out which copper it is.
Uh-oh.
So we're going to
How are we gonna do
uncrisscross.
Okay, take this too.
Uncrisscross.
Move it up.
That means the two
Take
had
the
to
one,
come.
it goes up here. Okay, so copper. Ooh, sorry, I don't know what I'm doing over there. Copper is gonna have a, come on, 2 charge. And what is NO3?
Nitrate.
Very good.
Thanks.
You're welcome. Magnesium chloride. Okay,
Magnesium.
that's
right out.
easy.
You even said it. Magnesium chloride.
I sure did.
You gave it to him.
Because once you know how to do it, it's really hard not to give away the answers.
Yeah, because your first word's always the name off the periodic table, and the second word, you're familiar with it. It's not anything off the cheat sheet. If you're pulling it off of the periodic table, ends in IDE.
So it's not magnesium chlorine, it's magnesium chloride.
Mhm.
Okay, Mn, what's that?
Manganese.
Again, I have to write this word. Manganese.
And then you've got your oxygen. Now there's multiple oxygens there, but that's not polyatomic. It's just 3 oxygens for every manganese. So that means manganese, if you look, it's in the transition group. So it had a 3+ charge. So we got to use the Roman numeral of 3 for our manganese, and then we're going to write oxide.
Sort of.
Why?
Well, because oxygen has a 2 negative charge.
Well, why did it disappear?
Well, we probably reduced it to the lowest factor.
Oh my goodness.
If you put a 3 up here, we're going to really, and then if you have a 1 up for the oxygen, you got to multiply this 1 by 2 because you have a -2 charge over here. That means you got to multiply this guy by 2 as well.
Oh, it's a tricky,
So
tricky.
that's going to give you manganese.
6.
Oh, wrong way. VI. I'm just going to do that
Yeah,
again.
let's do that again.
VI.
That's much
so
better.
that we are clear.
Yay.
Okay, and then oxide.
All right. You gave us a tricky
I sure did.
one.
All right. Oh,
Done.
done.
Section 4 we'll get to next.